So timer 2 circuit. So here in the PIC family, you are having three timer circuit: timer 0, timer 1, timer 2. So in that, timer 2 will play important role. Okay. So first we are going to see about the timer 1. So timer 1 is the most versatile and can be used to monitor the time between signal transition occurring on an input pin or control the precise time of transition on an output pin. So it will be timer 1 will be watching the time or monitoring the time between the signal transition which will occurring in the input as well as in the output pin. Okay. So in an automobile engine control application, input transition can be used to detect camshaft position, while output transition can be used to control the firing of spark plug. For example, they given the automobile engine. So in the automobile engine, the input transition is nothing but it will be detecting the shaft position. Okay. அதே மாதிரி அவுட்புட் டிரான்சிஷனில் வந்து it will be seeking the control of firing of spark plugs. Okay. So this transition, input and output transition of automobile engine is controlled. Timing control will be taken by your timer 1 circuit. Okay. And then timer 0 can be used to count external event. Okay, external event. Count external event, that is signal transition, generating an interrupt when a desired number of events have occurred. It can be even be used with its high-speed internal prescaler to accept input rates up to 50 megahertz, much faster than the PIC can deal with input rates on any other pin. So timer 0 can alternatively be connected to the internal clock that runs at one-fourth of the frequency of the uh, crystal clock frequency, that is 4 megahertz. Um, when used with its prescaler, it can be served as a loop time counter. However, the scale is not obtained as directly or as accurately as that obtained using timer 2, as will be seen. In this end of the chapter, a 10 millisecond loop time can be obtained with the timer 0, but untimely interrupts affect the loop time. So timer 0 is nothing but it will be used for external event counting process. Okay. So the counting timer nave counter now. Okay, it will be acting as a counter. So for the external device signal transition, it will be used. Timer 0 will be used. So whenever your external device request an interrupt with your microcontroller, that is PIC microcontroller, it will be the rate for servicing that particular interrupt will be fixed by your timer 0. Okay. With the help of prescaler. Okay, prescaler going to measure the timing rate. It may be from 1 megahertz to 50 megahertz. Okay, based on your request, interrupt request. Here, with the help of prescaler, timer 0 with the help of prescaler, it will be serving the each and every interrupt. Okay, so the timing, the prescaler with along with the timer 0 will be called as the loop time counter. Okay. Then timer 2 has significantly more freedom in setting the loop time than timer 0. So timer 0 with a timer 2 will be having more freedom on settling your loop time. Okay. So it will be taking minimized loop time for servicing the each and every loop present in the main program. Okay. So it has an alternative function that is constrained but not precluded by its use as a loop time counter. So timer 2 has the capability of doing alternative function also while executing the loop time counting. Okay. For this alternative function, it controls the period of a pulse width modulated output from the PIC microcontroller. So the alternative function is nothing but it will be having the control on pulse width modulation also for the output pin. Okay, output signal. Yeah, pulse width modulation output can serve as a simple digital to analog converter by driving an output pin with a periodic output for which the pin is driven high for x percentage of each period. That means your output pin, that is your output signal, will be having the connection with your digital to analog converter for that also it will be calculating or taking control over the that converter also, okay, by your timer 2 circuit. But timer 0 will not have this control at all, but timer 2 will have this external alternative function for performing all this process, okay. It will be doing the control over the pulse width modulation on the digital to analog converter which is present in your output pin, okay. So x percentage of period means, so your out periodic output will be measured at this rate, okay, x rate. So x is controlled by what is written into a ccp. What is ccp? Capture, compare, mode, which is present in your pulse width modulation. Capture, compare. So it will capture the time period and will compare the time period with your generated time period, okay. That is said to be ccp, capture, compare, pulse width modulator. So for an application that can use switching control, example light intensity control or heating element control, a pulse width modulation output is a valuable resources, okay. So for controlling the light intensity and heating element, it will be playing important role. Which one? ccp, okay. The specific loop time scheme discussed in this chapter will constrain the pulse width modulation output to have a period of 2 milliseconds, that is frequency of 500 hertz, short enough for many applications. So this loop time, specific loop time, which is generated by your timer circuit 2 will be playing important, is much more enough for many applications, okay. So you can use this timer 2 circuit for many applications. So this is the flow chart. So power on, you are calling the subroutine program, that is interrupt occurring, okay. So call will be blinking subroutine program. It will be indicating that your microcontroller process cpu is executing the subroutine program, and then call keypad subroutine, and then call loop time subroutine. Call keypad subroutine means whether how key debounce, okay. uh, how much time taken for executing the particular call, that is loop in the main program will be considered or calculated by the loop time, okay. This is the 10 million main line loop, okay. In the main program you are calling 10 millisecond subroutine program for execution, okay. So after 10 millisecond it will be written back to the main program, that is represented in this flow chart. ஸோ இந்த சார்ட்ல பார்த்தீங்கன்னா இது வந்து ஸ்டெப்பர் மோட்டார் இருக்கு. ஸோ ஃபார் எவ்ரி 6.67 millisecond your timer circuit will set for running the stepper motor. So stepper motor going to run step by step manner, okay. So it will be taking 150 steps for running that stepper motor for per second, okay. This is time diagram, timing diagram, relation between your loop time ticks, loop time subroutine, keypad subroutine, blink subroutine, mainline code, okay. So for every 10 millisecond what will be the uh, process. So the blink time for the subroutine program will be, for every 10 millisecond is represented here, but after some delay it will be represented, but exactly 10 millisecond only it will be taken. So அதே மாதிரி ஸ்டெப்பர் மோட்டார் இன்டரப்ட் சர்வீஸும் எவ்ரி 6.67 millisecond ஆக்டிவேட் ஆகுங்கிறதையும் இங்கே ரெப்ரசன்ட் பண்ணியிருப்பாங்க, ஓகேவா. அதை தான் இந்த டைம் டிலே இங்கே கொடுத்துருக்கோம். ஸோ அந்த லூப் டைம் வந்து 10 மில்லி செகண்ட் தான் எடுத்துக்கும். இது வந்து ஸ்டெப்பர் மோட்டாருக்கு தான் 6.67 மில்லி செகண்ட். ஓகே. Then interrupt logic. So interrupt logic is nothing but here you will be using scalar, that is main scalar with the prescalar and post scalar to measure the interrupt service time, okay, or loop time. This is your circuit diagram, timer 2 circuit diagram, okay, which will maintain the looping time of each and every interrupt which is coming from your external device. Okay, so counting of counter is maintained by the TMR. This is timer 2 counter. Okay, counter will be set and reset here by using this register, counter register. Okay, and then you will be comparing the value of counting with your count value which is set in your program or instruction. Okay, after it reaching the zero value, it will be returning to back to the main program. Okay, the diagram is represented here. This is the pic microcontroller, that is 16C74A or the interrupt logic. So interrupt logic is nothing but timer circuit. Okay, timer 2 circuit, this is timer 0 interrupt source. ADC module. So one more topic, ADC module in your third unit. So this will be your assignment topic. What is ADC?